The answer is to midpoint and distance. So which ones do you want me to work? Did you get 100? You did distance on a lot of them? Which one should I work? So it is not necessary to memorize your formulas. You may absolutely use the formula chart on everything. Just make sure you know how to use the formulas, because it is possible to use them wrong, to use them incorrectly. So make sure you've had a lot of practice, okay? All right. I need you actually, if you have tonight's homework, in our notes we're going to work some problems from tonight's worksheet. So if you do have it, awesome. If you don't, then you'll just have to write this down on some paper. One side says nth term quadratic, and the other side, and the other side says nth term linear. Okay, so we are going to learn how to find patterns in geometry. But it's really, we're stealing it from algebra, like I said. We're going to find out how to find the nth term of a pattern, which is really just finding the rule. We're finding the rule for sequences, and the warm-up, we did sequences that didn't really have, they weren't all linear or quadratic. But the ones we're going to learn today are all going to be linear or quadratic. So this is on your homework for tonight. It's number 5. So we're on the side that says linear. We're going to start with linear. We'll start with linear and then go to quadratic. We're on the side that says linear. So the first thing you always do is you fill in the values that they gave you. So you fill in the values. I'm going to go quickly because I know most of you already know how to do this. The next thing that you do is you find delta y. You find the change in y. Look at that. 4, 4, 4. Since it's constant, since delta y is constant, we now know that this is linear. We know it's linear because delta y was constant. So you take what you got for delta y, and that is your slope. That is your coefficient. It's your slope. Okay? And then you write the term 1, 2, 3, 4, 5, 20 in. And then the last step you do is called the tweaking step. Okay? So you see how much you have and you see how much you need. 4 times 1 is 4. I have 4 and I need it to look like 1. So how do you make 4 look like 1? Yeah, minus 3. Now check it twice just like Santa does, and then you can write it all the way down the column. What's 4 times 2? It's 8. How do you make 8 look like 5? Minus 3. So since we checked it twice, we can write it all the way down the column. So our rule, our nth term, is 4n minus 3. And I will call on you for the 5th term and the 20th term. Rishi, what is the 5th term? And Edriel, what is the 20th term? Good job, I gave you a hard one. Edriel, what is the 20th term? 77? Okay. Easy, easy, lemon peasy. Moving on. Okay. Number 7 on your worksheet. You know the drill. Fill in the numbers first. The way that you're finding delta y, by the way, if you weren't sure, you're subtracting. So you do negative 6 minus negative 2. And you do negative 10 minus negative 6. You subtract the second one from the first one each time. So what is our delta y? It's almost the same as last time, yeah. It's a little bit different. This time it's not 4, it's negative 4. So that's our slope, and we write it all the way down the column. Then we write our term. And then we do the tweaking step. Lars, you're off topic. Then we do the tweaking step. Negative 4 times 1 is negative 4. How do you make negative 4 look like negative 2? Plus 2. Good job, Johan. Plus 2. Check it twice, like Santa. 4 times negative 2 is negative 8. How do you make negative 8 look like negative 6? Oh, thank goodness. Plus 2. Once you've checked it twice, you can write it all the way down the column. So our rule is negative 4n plus 2. Our fifth term, Karthik, do our fifth term. And Alton, do our 20th term. Karthik and Alton. Yes, negative 18, very good. And negative 78. Okay, moving on. Now we're going to do one that's not on your homework, but I wanted to do a real world problem. One that isn't just abstract, like you're just finding the nth term. Did you know that the speed, well not the speed, but the number of cricket chirps in a certain interval of time can predict the temperature? Did you know that? It's really cool. So as the temperature gets colder, they chirp less often. And as it gets warmer, they chirp more often. So if you're sitting there and you don't know what the temperature is, but you hear cricket chirping, you can find out what the temperature is. Okay, so we're going to find out what the temperature is if you hear 32 cricket chirps in 14 seconds. So this is the number of chirps per 14 seconds. This is the number of chirps, and this is the temperature outside. This is the temp. We're going to start off like we always do, and we're going to do delta y, okay? So what's delta y? 55 minus 45, 65 minus 55. That's how they did it in the olden days. And you get, what's delta y? Yep, 10, 10. Now, something is different than our other ones. Something is different. Ooh, Quan knows. In all of our other problems, our delta x was just 1. So we didn't have any issues. But in this problem, delta x is not 1. So that's really important. We have to not only do delta y, but we have to also do delta x. In this example, delta x is 5. And so our slope is not 10. Our slope is not 5. To find the slope, very good, you know this from algebra, delta y over delta x. So our slope is 10 divided, oops, I'm saying the answer, sorry. 10 divided by 5, which is 2. So that is your slope. It's not 10. Be careful, there was a delta x, so we had to do something different. Okay. So now we put in our term, 5, 10, 15 in. Okay, all of us. Now we do the tweaking step. 2 times 5 is 10. How do you make 10 look like 45? Good, Karthik. Good, Ganesh. Plus 35. 2 times 10 is 20. How do you make 20 look like 55? Okay, we checked it twice. So our rule is 2n plus 35. What is n? What is n in this problem? The chirps. Very good, Chloe. It is the number of chirps in 14 seconds. So instead of n, we're going to plug in 32. 2 times 32 plus 35. And you get, what's the degrees? Good. It is a summer day in Houston, right? You should have gotten 99 degrees. The temperature is 99 degrees outside when they chirp 32 times in 14 seconds. Okay. So that's an example of how you would use this to solve some real-world data as long as the data is linear. You could use this table builder. Okay. Now we're going to go to the other side. So I need you to flip your homework over. If you have your homework, flip it over. And on the back, we're on number 3 on the back. Make sure yours looks like mine. 9, 21, 41, 69, 105. We're back to delta x just being 1, so we don't need to worry about delta x. So we're back to just needing to find delta y. So we do 21 minus 9, 12. 41 minus 21, 20. 69 minus 41, 28. And then this one should be, what, 36. Okay. Now, wait a minute. When it was linear, delta y was constant. We got the same number every time. But this one is not linear. We're not in Kansas anymore, Toto. We are in a different realm. So this is not linear. We now know it's not linear. When it's not linear, we need to try again. If at first you don't succeed, try again, right? So instead of doing delta y, we're going to do delta y. We're going to do the change in the change of y. The change in the change. Delta y is 8. Now, here's the deal. 8 is not the slope. You don't write 8 all the way down the column. Because we did delta y twice, and it kind of has to do with derivatives, which you'll learn in calculus, the reason that we do this. But the reason that we do this is because we did delta y, and because we have an x squared going on. And so instead of putting 8 all the way down the row, you're not allowed to put 8. You have to take delta y, and you have to divide it by 2. So I just want you to think of, okay, I did delta y twice, so I need to undo that. I need to divide by 2. Okay? So our slope is not 8. Our slope is 4. And you write it all the way down the column. So we took our delta y and we divided it by 2. That is very important. If you don't divide it by 2, you're going to be stuck with the wrong answer for sure. All right. The other thing that you have to make sure to do is because this is quadratic and not linear, you have to square your term. So you don't write 1, 2, 3, 4. You write 1 squared, 2 squared, 3 squared, 4 squared. Those are the two things. You divide by 2, and you raise the number to the 2. So there's 2 2's that you have to do, 2 2's. Sometimes we call it the 2-2 rule. You had to do 2 2's. So we had to divide by 2, and then we have to square the term. Divide by 2, there's one of the 2's, and square the term. There's the other 2. There's 2 2's that you have to do, so we call it the 2-2 rule, like a ballerina. 2-2, yeah. So don't ever forget the 2-2 rule when you're doing quadratics. All right. The last step is always the tweaking step. 4 times 1 squared is 4. How do you make 4 look like 9? Let's look at the next one. Yes, when it's quadratic, Abby. When it's quadratic, when you do delta y, you always do the 2-2 rule. All right, 2 squared is 4. 4 times 4 is 16. How do you make 16 look like 21? Plus 5. So now you can write it all the way down the column. Now we can find the 20th term and the nth term. Oh, Chloe's already gotten it. 1605, 1605. And the nth term is 4n squared plus 5. If you leave off the squared, you get it wrong. 4n squared plus 5. I'll put her card at the back. What is the reason you have to divide by 2? It stems from when you take the derivative of something like this, which you'll do in another class. When you take the derivative, you multiply. Oh gosh, I don't even remember the term for this because I haven't taught calculus in a long time. When you take the derivative, you multiply the x by the exponent, and then you subtract 1 from the exponent, and so you get 2x, and then you're kind of undoing that by doing the 2-2 rule, and that's why you divide by 2. But you don't need to know all of that. You'll learn that in another math class. All right. Let's try number 4. I'm going to let you try number 4 by yourself without my help, and then we'll talk about it. Go. Okay, so y'all are telling me that for delta y, you got 4. And so for your slope, it would be 2. Is that right? Is that what you're telling me? Okay, good. So that's the first part of the 2-2 rule. It is to divide by 2. Take your delta y and divide by 2. The second part of the 2-2 rule is square the term. The last part is the tweaking step. Relina, what did you get for the tweaking step? Relina, what did you get? Good job. Plus 3 all the way down the column. Johan, what did you get for the 20th term? Johan, 20th term. Five, 4, 3, 2. 8,003. It does seem simple. I'll make it less simple tomorrow. How about that? Yeah, oh, sorry, 803. Yeah, 803. And then the nth term is 2n squared plus 3. That's the rule. Okay, we're almost done. We just have a few more real world problems. Write an equation that would represent the area of a package A if she sends C care packages. So, we're always going to start by doing delta y. Every single time, delta y. Let's make the care package smaller so I can do delta y. Okay, so you start by subtracting. 18 minus 16.5, oops. $20.5 minus 18. So, delta y was not constant. So we know it is not linear. We know it is quadratic. So now we need to do delta y. And we get 1, 1, 1, 1. Okay, good, Rishi. The slope is not 1. Since we did delta y, we have to take our slope and divide it by 2. So our slope is 1/2. The next thing we do, since we know it's quadratic, is we square the term. There's 2 2's, the 2-2 rule. You have to do the 1, you have to divide by 2, and then you have to raise the term to 2. 2-2 rule. Stop spamming the chat. Stop. Okay, thank you, Quan. Okay. So, how do you make 1/2 look like 16? Well, that's easy. 16.5. You just add 16. How do you make 0.5 look like 16.5? You just add 16. Okay. So now we're about to find out what kind of box she needs to buy. So actually, now we need to write an equation that would represent the area of the package. A equals 1/2 C squared plus 16. So since they told us to use A and C, we would need to write an equation with A and C. I didn't double check like Santa. You're right. I'm sorry. I just trusted the 16. All right, so if she's going to ship 8 care packages, what needs to be the area of her box? 8 care packages. 8 squared times 0.5 plus 16. The area of her box would be 48 square inches. 48 inches squared. Oh, that's all. We're done. Yay!